Starting the recording. Hello, everyone. Welcome to the May 11th, 2022 meeting of Sig-AUTH. First thing on the agenda is that the 125 enhancement freeze is coming up on June 16th. So let's make sure that we get our keps in that for changes that we want in 125. June 17th enhancement freeze. Okay, moving on to polls of note. Who put this one on here? Did anybody want to speak on this one?
Sorry, that was me. I just wanted to, I'm not sure we need to discuss it. I just wanted to announce that this was merged and it's official. Not that it wasn't official before.
I think this deserves a round of applause. All right, awesome. So this is going to be in 125. Congratulations, everyone. Is anyone on the call who can lead this discussion?
Sorry, my internet broke up. About who am I?
Oh. Yeah.
This came up at a couple different calls. And one of the questions that I had was actually for you. I seem to remember like 7 years ago, Mike, saying that he had concerns about allowing someone with possession of a token to determine the identity that both that token represented. And I wanted to make sure you had a chance to say whether you had a concern. The idea being that you would be able to take a token and say, or just connect to the server and say, who am I? And it'll come back and say, you have connected as David Eads, you're a member of these groups, this is your user extra, this is the content. It's essentially a token review if you are in possession of a token.
Right. So I think the thinking back about the concern, what I was probably talking about was kind of in like an OAuth scenario, we would require something like an email scope to allow an OIDC client to determine what the email address associated with that token is. So I don't think, you know, like speaking specifically about Google OAuth, we wouldn't consider possession of a bearer token to automatically grant, you know, access to read stuff like email address. I think that might be I'm not sure if that is specific to Google. I guess I would like to hear from you know, people familiar with other identity systems.
So OpenShift run. Oh, I'm sorry. Mo has his hand up. You can go first, Mo.
You might have started talking before I raised my hand, but what I was going to say is like one of the existing integrations that we have today in Kubernetes is the OIDC authenticator, which uses the ID token as the mechanism for authentication, which is interesting. One, because it really annoys the OpenID Connect folks. They're not a fan of that. They're like, you're supposed to use access tokens for this, not ID tokens. But you know, as an aside, that token itself, tells you at least your username and group sort of just directly. It doesn't necessarily tell you, well, it might also tell you UID depending on how the system is configured. But so that's like one sort of, I wouldn't say it's a precedence, but it's at least a model that has information available to the user. Maybe they don't explicitly know it because they might not look at the ID token. The other thing I was going to mention is, if you were asking just third-party external, so like the Tanzu auth stack has a whoami command basically, which today is implemented using an aggregated API that simply echoes back what the aggregated API server saw about you. So like which today means username, groups, and extra. It doesn't include UID because of a bug in the aggregation there, but otherwise it includes the full information. But that API is accessible by anyone that's authenticated. It's not meant to be secret anyway.
Mm-hmm.
So
yeah,
I guess I'll bring up one more example, and it's Openshift. It's different than the Tanzu case. Openshift runs our, I think it's different. Openshift runs our own OAuth server internally, which mints tokens. And that means that there is, we only expose the information that Openshift has. And so things like a user email that's dropped, things like what the OIDC integration you may have put behind the Openshift OAuth server, all that information is dropped. And so we feel pretty confident about what we return, not exposing something like an email address. I don't know whether Tanzu falls into the same case.
So for us, the information that is exposed is the information that's going to be presented to the Kubernetes auth stack. So basically exactly what's in the user info interface is what we expose back. But yeah, if there was some other metadata that the auth stack had access to, like your home address or something, because you decided to include that in the scope of the OIDC client or anything, we don't include that in the tokens that are being sent around, so it's not exposed. I think in that sense, David, it matches OpenShift basically exactly, which is just whatever Kubernetes sees is what we send back.
Well, but it's not, you're not taking the token that the user identified with, like if say Google OAuth, you aren't taking the Google OAuth token or the token that you get back and saying, this is the one I'm submitting to the Kubernetes server, let me tell you everything about it. You're also minting some sort of intermediate where you have your own token authenticator?
Yes, exactly. So just as OpenShift effectively federates some external IDP, which may or may not have tokens, the Tanzu auth stack was basically the same thing. So yeah, you are right. In the Google case, it's different in the sense that Google itself is an IDP, and in the GKE case, it's like directly integrated as the IDP within the platform. So like those basically those tokens can have a meaning outside of Kubernetes, right? If I'm understanding right, Mike. Which
right. Usable against other cloud platform APIs, for example.
Yeah. In the Tanzu case and also in the OpenShift case, they can't be used outside of the Kubernetes environment.
Yeah, I also will say that this isn't a concern for GKE really, because in the case where the token doesn't have user info scope, we'll just return UID corresponding to the user, which is like equivalent to what we do with RBAC. So if you authorize with RBAC and you don't send user info scope, you have to use the numeric UIDs rather than email addresses. So that is to say, if you think this is going to be useful, there's like no, I don't think there's a practical concern from me at this point in time. How would you model this or implement it? Would you plan on creating a new API kind under the authentication API group?
I don't know if the person who wanted to implement it is here.
I see
Okay.
Max on the call. I can, Max, if you want to go, you can, if you have an idea. I have an idea, but I can let you go.
Yeah, at first I thought, can you hear me?
Yep.
So at first I thought about one more endpoint like token review, yeah, just to get the user attributes, and that was like a first thought of mine. But if you have something better on your mind, you can go on.
The thought I had was an ephemeral REST API like token review and subject execute, all of those, the auth in, auth, so something like that, but one that just basically takes in. So at that layer within the stack, you've already authenticated. The system already knows that. You've already also authorized and everything. So it would be basically just turning around and sending back what it knew. So the idea is that it would be compatible with like any front proxy or anything else that you had doing auth, like basically no matter what. Because at the end of the day, they have to tell the Kubernetes API server who you are. And this API is basically just going to turn around and say, after whatever magic happened in front of me, this is what I understood to be the user, whether it's a token, a front proxy, or whatever. I'm just going to send that back to you. So it's completely detached from any authentication mechanism. So for example, it should work exactly correctly in Openshift. It should also work correctly in Tanzu for any kind of credential the cluster understands. It's kind of the gist of what I was thinking. Yeah.
Yeah, I believe that that would probably be the ideal implementation. Having a separate API, kind of like subject access review.
Would you want the verb to be like a create? The reason I ask is, would you want admission to be able to intercept and stop this? Or somehow do something weird with it? I don't know.
I would expect it to be a post to be consistent with our other.
Yeah, that's what I thought. I just wanted to get, because in OpenShift it's a get, right, David? It's a get of the tilde user, which is not a mutation.
Correct. It is a get at a specific URL. There's already a user object type, and we reserved tilde.
David, do you have any concerns that this is a different, this would be a post and not a get, or do you think that's fine?
I don't see why I would choose one over another, really, right? We mark it as uncacheable. This would still be uncacheable. So, seems okay.
Mark, Longo?
Awesome. Oh, yeah, it sounds to me like there's no objections to this, and maybe the next step would be propose the design in a KEP.
One thing I would like us to clarify here, if we can, I don't think I see this as ever being required for conformance. Do we see a state differently for that? And I guess a KEP would want to cover that, so we agree to it there. Not because I want to turn it on, but because I can imagine other people not wanting to turn it on.
David, remind me, if an API is fully GA but not part of conformance, does that mean you can turn it off? Is that what that means?
Yes.
Okay.
For instance, RBAC is not required by conformance.
Yeah, I mean, I don't know if I care one way or the other. So a client would be able to see if it's present in discovery, right? If it's or see that it's not present if it's disabled. And if you had like a kubectl who am I command, it could say that this API is disabled on the server. Please contact your admin or something.
Yeah, probably. I'm just saying I think a KEP should cover it. I think we should decide what we think is best for explicitly, not just like by momentum.
Yeah, I think that's fair. I don't necessarily feel strongly one way or the other as long as it exists and is easy to use.
Awesome.
Max, do you have any questions for us? Anything to...
No, everything's clear. Thank you. Thank you for this detailed discussion. I will try to write a KEP like till June.
Awesome, thanks. So next one is the KMS v2 KEP. Sharita put together.
Hey, do you mind making me a presenter?
Sure.
So I can walk through it hopefully quickly.
Yeah, just a second. Okay, you're a co-host.
Yep, thank you. Can you see my screen okay?
Yep.
All right, sorry. Okay. Anyway, so this KEP is pretty long, so I'm gonna try my best to go through it quickly. But as many of y'all are already aware of, there are a bunch of improvements for KMS as is today. And this KEP actually proposes V2 of the KMS service contract, specifically to enable fully automated key rotation for the latest key, improve KMS plugin health check reliability, and improve observability of the envelope operations between API server, KMS plugin, and KMS. So, and actually this one was already discussed in a different KEP, and it was actually reviewed and approved. So we are actually just merging it as one because all of these are part of the V2 proposal. Moving on, there are tons of motivations for performance enhancement, how to actually enable automated rotation as we have manual steps today, and of course health check and status as a separate API today, and observability as I mentioned above. Moving on, and also we have Anish, Mo, Christoph, and Damien on the call as well, who have been working on this KEP with me. So folks, feel free to jump in at any time. All right, so moving on, we're gonna first talk about the key hierarchy in this proposal and what this means and how it can help with performance enhancement. So we thought a picture is worth 1,000 words. So here, as you can see, with this proposal, the new V2 API will basically enable us to allow something like key hierarchy. So for encryption request, as you can see here, when we are using key hierarchy, when the API server talks to the KMS plugin, it basically makes a request to encrypt the deck with a local KEK. And here the external KMS then encrypts the local KEK with the remote KEK and returns the encrypted local KEK, right? And once that's returned, then we actually cache the encrypted local KEK and return it as part of the encrypt response. And now, as you can see, Cypher is now updated to Cypher text. And then we introduce a new current key ID, which I will discuss later as we will use it for rotation. But specifically metadata here is introduced specifically is something that we could or any plugin could potentially use to persist this encrypted local CAC to SCD. And when key hierarchy is not used, it is pretty much the same as today. As you can see, the remote CAC is what is used to decrypt, is what is used to encrypt the deck, and then encrypted deck is now returned as part of the encrypt response. So this part is no different than what it is today. And the metadata is empty. Moving on to the decrypt request. Here, as you can see, assuming you're using the local CAC and it is part of the metadata and it is sent as part of the decrypt request, right? As you can see here, then the plugin will basically decrypt the deck with the local CAC if it's already in the cache. If not, then we will make a request to the remote CAC to actually decrypt the local CAC, and then again, return the local CAC and store it in the cache and return it as part of the decrypt response here. All right. And similarly, if we're not using the key hierarchy, then it is pretty much the same as today. I'm going to pause real quick so we can discuss the key hierarchy real quick before we jump into rotation.
Is there anything about the V2 API that enables this?
Metadata.
Could I put like a prefix on the ciphertext with the metadata today that I hand back, since it is kind of opaque to Kube API server?
There's not enough space because we store the length as like 2 bytes or something. So there's not enough space in the length. You'll run out of space very quickly.
Oh, we have
Oh yeah, it's not a well thought out API, right? Today, if you spent back too much data in the encrypt call, it'll just write trash into etcd.
Weird. That is unfortunate.
Yeah. Now, I don't think anyone does that today. They just encrypt the deck, hand it them, and it's not that different.
Right.
And maybe we should talk about the proposed storage, the format, the new format.
Yeah, I can take that if you want, Rita.
Go ahead.
So this basically is meant to look very much like the existing protobuf storage format we have, but it uses a different magic prefix to indicate that it's being used. And instead of storing a runtime.unknown, you know, as a way of figuring out what it is, it always stores the exact same thing right now, which is an encrypted object that's meant to store the ciphertext of like the encrypted data, but also the full encrypt response. So that includes the full metadata and everything from the plugin. And obviously we would very carefully document to plugin authors that part is stored unencrypted, in the sense that we don't store it in any encrypted format. We store exactly what you gave us. And when we try to decrypt something, we send that all back. The idea here is to get away from basically using like the CryptoByte API and just continuously just packing length prefixed data into like a flat slice and use a nice structure. Like the rest of our stuff. Does that make sense? Am I making sense here?
Yeah.
One thing that this still has a weakness that the existing API has is the fact that it encodes the name of the plugin into the storage. I couldn't come up with a way, at least yet, where we didn't do that, unless we were willing to like try to decrypt an encrypted object with every configured CAN-MES provider, which seems also bad. So that's still a weakness of this proposal, which is that whatever name you chose for the plugin in your encryption configuration is what it's going to be stored as. And if you don't like that, sorry, you can't change it because we won't be able to find the data again. if folks have better approaches, I'm totally open to it. Let's see what else. What else is there? I think that covers the storage. It's just basically a nice proto storage instead of a flat cryptobyte based slice. Rita, do you can talk about status stuff or?
I can jump into rotation if there's no more questions on the key hierarchy. Again, this CAP has a lot of stuff, so I want to divide and conquer and focus on one topic at a time.
I was going to mention on the key hierarchy thing.
Yeah.
Key hierarchy is not in the Kubernetes.
Right. It's actually.
It is technically an implementation detail of the KMS plugin. What we're saying is that we will provide you a reference implementation that can do a key hierarchy if you tell it to. It is not a requirement of said reference implementation. The assumption being there that the performance hit from KMS comes from external gRPC or REST API calls to an external KMS, but that the local gRPC calls over the Unix domain socket are not that expensive. We have done some limited testing to see that this is indeed true, but I think as part of even the beta criteria for this CAP would be to do a significantly large cluster with at least 10,000, 100,000 secrets and prove that the local gRPC calls are not the ones that cause the system to bottleneck. Because if they are, then we would need something better. We would need something within the API server to help break that up. Am I making sense? Well, I know I'm talking about a bunch of stuff.
Yeah, cool. I think that's easy enough to test, though, once we have. Yeah, so I guess the one thing on the storage format is we should evaluate whether we want to continue to keep it opaque to Kube API server or whether we need kind of structured metadata. Not sure which one is preferable, because one option is to just remove that limit on what we pass back for the encrypted key, so that the KMS plugin can define their own format for the envelope, or I guess for the associated key data.
So I think, and we don't need to necessarily rabbit hole on this, the API that is being sort of proposed has both structured bits for the bits that we want to have opinions on, but it purposely tries to leave basically a labels map of string to string as available storage for the plugin. Basically ask us to hold on to some metadata for it. Today, that metadata is just a string to string. Certainly, if we wanted more structure, we could add more fields to the request and response, wherever it makes sense. Yeah, I didn't know if there was other things that we would want to support. Like, for example, I could see the plugin wanting to maybe include some metadata about the external KMS in its response, just for the purposes of making debugging or understanding of the system state better if you're just looking at a raw etcd dump. And so we wouldn't want to I didn't want to force them to put that into some opaque value, right? I wanted to at least give them a structured map to just put stuff in. So yeah, this is a pretty massive CAP. So if folks want to very carefully read it and think about things and make suggestions, I don't think any of us are married to any of this. It's more of this is the closest thing we could come up with for a good alpha.
Yeah, Rita, do you want to hop on to your next topic or?
Yeah, rotation, sure. So the next one is, as I mentioned earlier, we're also introducing current key ID, and then also a new status API here. One is to improve health check reliability, but also to provide version health Z, and also a mechanism in which we can trigger key rotation via the storage version status updates. So this is sort of how the new V2 works together in order to actually allow the API server to check on what that current key ID is between all the different API servers, and then be able to trigger a rotation and a migration when that's detected. And also, as Mo mentioned, since this is currently alpha, this KEP will basically try to scope it to a single API server for now, until we have something a little bit more stable for the storage version. Anything anyone else wants to add?
So is it desirable that a single KMS plugin can serve two different keys? Maybe like if you are not two different key versions, but two different keys, like if you want to change from, you know, one key to another key.
So I think yes, Mike. So I think what this API is trying to express is that today, as far as like storage migration is concerned, to cause key rotation, the only way our code knows that something is stale in terms of the like storage transform layer is if the actor that was used to do the read from storage wasn't the first one on the list, right? So what this tries to do is to, in addition to that, also support a single KMS instance being able to say, hey, I see you asked me to decrypt some data or whatever for an update call. That used this key ID at some point in the past, but the one that I would do future writes with is this other one. So technically that's stale, even though API server, you can decrypt it because you have everything cached. You still need to mark it as stale for the purposes of storage migration. That's basically what the whole current key ID thing is doing, is basically giving a way for the KMS plugin while it's running to change what it believes to be its current write key. So it can have as many read keys as it wants internally. For example, we you know, in some of the reference poking around we did with Azure, we were able to see like if you had encrypted stuff with a different key, the plugin would notice that it didn't have that key around, and it would just go fetch stuff. I mean, it would just make external calls and go ahead and fill its cache and do the decryption anyway. But it would then return what key it used to give the API server an idea of like, oh, I see that's not the key that you want to use. So that means it's stale. David, I saw you unmute if you wanted to ask.
Yeah, I happen to notice that the API doesn't seem to separate the notion of read keys from write keys. And that surprised me. I sort of would have expected to see like, these are the read ones that I can interpret, and this is the write one that I'm using.
Mostly in the sense that, I mean, we could, if we want to expand status to also include all possible keys that the plugin knows about. The idea there is that when it encounters a key that it currently does not understand, it will ask the external KMS to help figure out what that opaque string means based on whatever APIs exist for that external KMS. So the only, assuming there's no bugs in your KMS plugin implementation, the only way you're going to be presented with a particular key ID during a decrypt request is if at some point in the past, you or another instance of your plugin used it. So it'll be in external KMS unless it's been deleted or something. So that's kind of like, so we could, if we want to, within status, include some capability for the plugin to say, here's everything I understand. I don't know if that's a good idea because, well, I don't think it's necessarily a bad idea. I think the concern I have is, what if the external KMS does understand some other key that we might not necessarily know about, but it's okay as long as it can do the decryption for us? Like basically, would we prevent the API server from making the decrypt request if the plugin said that it didn't know about some key, or would we still just make the decrypt request anyway?
Yeah, I guess would the API server use that list, and how so?
Yeah, I think that's a more succinct way of just asking the question I just asked.
Yeah, I guess I'm used to the implementation of key rotation in Openshift, where we do keep track of who can read what. Can everyone read the version that someone else is writing? Once everyone can read a particular version, we can then promote something to a write key.
Right. So
practical usage, you would want to know everybody can read this new key first. Yep. All right. Now everybody can write with the new key.
yeah. So in this design, it explicitly makes a comment about that there's no coordination required between your plugin instances. So in particular, that type of coordination is not required in this design. So when a particular instance of the KMS plugin changes its write key, it does not coordinate with any of the other instances, and that's explicitly okay.
Yeah, can we make a suggestion that the available decryption keys include next key, current key, and previous key, and make sure that the next key is available for decryption a while before we start using it for encryption? Is that something?
I don't know what that gets us in this design, because the way it's meant to work is, like, say you have two API servers and one of them notices, like one of the KMS plugins to API server A notices the write key change first. If it immediately starts using it, if API server B then tries to decrypt some of that data, it'll totally work fine. Like it works fine in like our implementation stuff today, because what it does is it basically asks the external KMS, hey, can you help me do this decryption? Because I just saw a key ID that I don't currently know about, but you probably do because you're the external KMS. But basically, it uses the external KMS as a full coordination actor, right? So like you can't go to a key that the external KMS doesn't understand. That's basically the assumption it's making, which I think is true in the case of external KMSs in general.
Is it always true that external KMSs are consistent?
I guess that is an assumption of this design, that if an external KMS lets you use a particular key, it's ready to be used across its API boundary, whatever that is. I guess that's not necessarily true. That would be something that we are. That is something that we are sort of explicitly asking, though in the implementation of your plugin, if that wasn't true, you could purposely wait before moving if you knew some criteria.
Right. So that's the benefit of staging the new keys as available for decryption well before they are actually used for encryption.
Right. So what's unclear to me, and if we tried to do it that way, is how would then the API servers coordinate this among themselves, right? We don't have a mechanism. This tries to avoid building such a mechanism.
Right. I think you just don't, and say a day is probably enough for your KMS API to become consistent, or like if you're rotating every day, the next key is available for decryption a day before it's used, or something like that.
I mean, I guess the other point is, like, today all this is done manually, right? Like this proposal isn't like a regression or anything, right? Like,
right.
So this in essence should improve the current experience. We're not losing anything here. And if anything today, I as the operator will have to manually go check, is that next key available for read and write?
Yep, definitely. But I think like the ideal usage is important to understand when we look at when we review these designs. Even if, you know, I think that you are right in that this is out of the purview of what Kubernetes will be responsible for. Like what would we put into operator docs? But yeah, I think we have pretty reasonable answers for that, it sounds like already. If there are other things in this doc that you wanted to get to, Rita.
I think those are the two big ones. Other than that, we are adding support for hot reload of the encryption configuration and introducing the new UID field for observability, which was touched on in another cap. So that's the big items. I don't think I missed anything else, right?
I was gonna explicitly ask.
Anything else?
David, do you have any concerns about hot reload of encryption config? Because I know it would change stuff in OpenShift technically.
So I would be interested in talking about or discussing whether loading a new configuration that is invalid in some way should result in, you know, I no longer serve, or if it should result in like I freeze, or if it results in I serve last known good. I would be concerned about those edges.
Yeah, totally. I'm concerned about them as well.
That's a good one.
The proposal basically says, right now it says it'll just keep serving last known good and complain loudly in the logs. I'm not saying that's great, but that's what we had.
Okay. I'm not against it. I'm looking for, oh, she's highlighting it on the screen now. I was looking for, yeah, at least precise expectations can be set there.
Mm-hmm.
Specifically, I think one thing that I think all of us don't want is some weird partial middle state. That is not what we would have. You go from a perfectly working configuration to a different perfectly working configuration, but not something in the middle.
Yeah, and how that gets exposed in the storage version API is also interesting. You know, is your current key the one you're using, or is it the one that's configured? But yeah, you know, explanations like that. But otherwise, no. Hot reload for this seems.
Yeah, so I in OpenShift, assuming, you know, the work I did was correct, it would never generate a config that was not immediately valid because it never tried to skip any steps, right? It never tried to promote a write key before it was ready.
Yeah, yeah, I think it would continue working, and someone who writes something invalid should expect something weird to happen. We just need to be able to tell them what that weird thing is.
On the storage version status thing, I mean, this part is like the most dubious part of this kept, because it's basically saying, hey, if there was this cool other API, I'd like to use it. I don't know really what to do with that. A part of me is like, maybe we shouldn't include it in the kept at all because we can't realistically rely on it being present anytime soon. Or for those on the call that weren't at the Sig-API machinery meeting, originally I had wanted to use the storage version hash from Discovery, but I was told, one, that field will eventually be deleted, so don't use it. And two, there was important and significant concerns about the fact that Discovery is accessible by most actors on the system. So even though it's technically completely opaque, it does leak information about the system's internal state to basically all authenticated users, and that doesn't seem like a great idea, and I agree with that. So this API, this other one, doesn't have that problem, but it has a different problem of being alpha and currently not having an owner to push it forward. And also it seems like a hard problem in general. So I don't know if folks have any thoughts.
It's kind of cheating, but since I was on the other call, I will also mention I encouraged you not to use a field we're planning to remove. So there is not currently someone slated to bring the storage version API into beta, just so you're aware of that as well.
Do we have guidance like for the overall Kubernetes project for like if you're building a feature that wants to rely on some other feature and that feature is not done, how do you progress? Like would we try to block on it, or do we try to have partially working functionality that only works when all the feature gates are in the right state?
There are other people building like optional pieces of their feature. I think I am aware of cases where work that relied on other work, they ended up pushing that other piece of work through as well. But that was usually same set of people.
Okay. A completely meta question about this. So I feel like I was too closely involved in this KEP to be an approver on the KEP. That's just basically rubber stamping your own work. Do we have? I don't think Clayton's on the call. So does anyone want to step up as a approver for this?
I can review this.
Okay.
Cool.
Go ahead, Rita.
Thanks. I think that's pretty much it. And if there's nothing else, we can go to the next item.
Awesome. So I will reshare. The next item is you, Mo. Maybe if I don't know. So we have two items left, Tim and Mo. So Mo, I will give you 5 minutes.
Awesome. All right, gotta talk fast. So I realize you're not sharing your screen yet, but I'll just keep going. We discussed this a while back, and David has taken at least an initial peek at very rough KEP. But the gist of what the KEP is trying to propose is right now it just proposes a code level change that basically says within Kubernetes client Go, we will be able to assert that, assert the configure TLS configuration of the client. So not the server, but the client itself. In particular, being able to fully opt into TLS 1.3 or stay at TLS 1.2 and control the ciphers therein of. Today, neither of those things is configurable. It's just sort of hard coded in client Go. And David has rightly pointed out that if the KEP as written right now basically only provides valuable to maybe like a library author, it does not provide end user facing value because it's just talking about internal code changes. I don't disagree with that at all, by the way, David. So yeah, I'm totally open to trying to expand this out into some kind of configuration for like the API server and controller manager. I am nervous about trying to expand this into like kubeconfig territory, because then it starts showing up around things like kubectl and like some of the webhook configuration and maybe ways that are not great. And I'm not sure how to do feature flags for any of that stuff. I know how to do feature flags for API server and controller manager. Also, the proposal is there's some atomic knob that lets you flip change whatever the default of the system is to some other default. So instead of like TLS 1.2 with no cipher config as the default, you would say I want 1.3 or 1.2 with some ciphers as my default when not otherwise specified. And then on a particular REST config or a particular transport config, a client could say, I don't care what the default for the process is. I'm going to be talking to server A, and that server has this config. So I'll go ahead and just wire that in myself. And if I make a client from that REST config, it's going to use that TLS configuration. And then it could also choose to make a different client with some other TLS configuration. That will also be fine. In particular, there's a lot of internal clients within our code base that aren't really exposed out. Like I'm thinking about inside the API server internals. Those would almost certainly primarily be using whatever the process level default is.
So why is the client-side configuration needed when we have server-side configuration?
You don't always control the server, right? So you can, in cases where you do not control the server and you are connecting to something somebody else hosts, you could still wish to say, I will only speak to this server using this protocol.
Yeah, that's basically it. Like as a for example, like the default TLS config that we have today will let you use triple DES, because that's when you don't specify any cipher suites, Go is fine to drop all the way down to triple DES, which is meh.
It will let you, but it will never actually use it, right? So.
Well, no, that's what I'm saying is if the server says I only support triple DES, then we will happily connect, right? And when I'm saying that's a bug, I want to not connect, I want a failure, because you don't notice, right? So there's the other aspect of, even if you control the server, you might have infinite numbers of proxies between you and it, and if some of them do things that you don't like, you want to know, right? So it does give you a way of affirming on both sides of the equation. I do understand the point though. The server side config is significantly more critical, but we already have it today.
Mm-hmm. You said this would be process level?
It is both. You'd be able to override the process level configuration. So if your existing code isn't setting the new fields in REST config, it'll get whatever the new process default is that you've changed from the existing default. Mm-hmm. And if you set the fields, then those fields would be honored. In particular, right now, there's no provision for saying, I have this process default and it cannot be overridden. That's not in the KEP right now. If we wanted to have that, we could. So you could get extra pedantic and say you can only use like the 5th ciphers, and I don't care what the rest of the code does. I could still see that being valuable if you have a piece of code that you fork and you want to contort it in some way, and you don't necessarily want to go patch every client in there.
Yeah, there's nothing obvious to me that is concerning about this. Why don't we give this 2 weeks for people to review and come back to it?
I'd like to call out 2 specific things about this KEP as we're talking about it here. One is that it talks about going direct to stable, and I'm not convinced at this moment in time that that is suitable, especially when combined with the fact that, as described, there's no way for us to actually see it working, right? You can't use it in Cube. Now, once that gets added, that concern will be diminished, but at that point, I'm looking and saying, well, usage of this thing probably ought to be feature gated. The other aspect that caught my eye was in many of the cases where we make connections from a Cube API server out, the only piece of information describing how to make that connection is a Cube config. And so I am not at this point convinced that moving to stable without a way to use it in those areas is where we want to go. And so those are 2 areas when people review the KEP, I encourage them to read, and hopefully Mo will elaborate as to why choice A and not choice B, and we can discuss it there.
Yeah, I was a quick thing. If just based on the feedback I've gotten so far from you, David, I think I would expand it to at least allow like API server and controller manager config of this, like the global process default. And once that's there, then this would go to the standard alpha beta GA cycle, just because then it's exposed in a way. The thing I was saying was just going to be stable as is, basically just a code level change of client Go. But yeah,
unused code I don't trust to ever work right. So okay, that'd be a great update. I will have a look when that goes in.
Awesome. Tim, conformance for pod security GA.
Yeah, so this is just a follow-up from what we discussed last week of bringing pod security to GA. I wanted to get this PR out earlier, but apologies for the last minuteness of it. The one thing that we had on here that we didn't talk about last week was conformance test plan. That was previously an unresolved thing for GA. I basically copied what we had from the conformance future extension into here, saying that basically the default pod security mode is enforce at privileged, which is a no-op, so that shouldn't affect conformance of any clusters. The ETE framework has been updated already to explicitly mark namespaces with the required level. I think most of those are actually overprivileged. And so probably I'll work towards scoping those down for 125, but I also don't think that needs to block GA. And then the last thing is just an explicit note that pod security admission is not required for conformance. The one question that I wanted to raise, I left it in future extensions, but this question of whether a cluster that requires baseline should be able to pass conformance. That's currently not the case. A bunch of namespaces are marked privileged that have conformance tests in them, but a quick scan looked like a lot of those was just defaulting to privileged and actually didn't have any privileged pods in it. So we might be able to get at least close to that. I'm sure that we can't do that for restricted without substantial changes. And I think probably that would require the conformance profiles feature to move forward. So I know we're kind of at time. I just wanted to mention that here. Feel free to chime in on the PR or add your last minute thoughts.
Awesome. No, that sounds all reasonable to me. Cool. And we're at time. Thank you, everybody. I guess I will see all of you in 2 weeks.